This podcast is going to talk about the Mayneord F Factor. John Smith has a really nice description or a derivation of how do you get to the equation of the Mayneord F factor. It's very elegant. I'm not going to go over that here because I consider that for your practical case a complete waste of time. Not only, number one, does anybody ever use the Mayneord F factor anymore, because hardly anyone does percent depth dose patient setups anymore. Number two, there's absolutely no reason in learning how to derive it, because on an exam they're not going to ask you to derive it. They're going to give you a plug and chug problem. So there's a trick, there's a mnemonic device that I use with the Mayneord F factor, and hopefully you will remember it and be able to use it on your board exams, because you will undoubtedly probably have one or two Mayneord F factor problems. The mnemonic device is 2112 D max before depth. 2112 D max before depth. Let me write the Mayneord F factor equation out, and then I'll show you how it corresponds. Mayneord F factor equation, you might see this written differently either in this course lecture notes or in books, and it's probably because they've just switched the top and the bottom around, but the math works out the same. Here's where the mnemonic device works in. 2, 1, 1, 2, D max before depth. So SSD plus D max, SSD 1 plus depth, SSD 1 plus D max, SSD 2 plus depth. 2, 1, 1, 2, D max before depth. Okay, the Mayneord F factor is used when you have a machine that's calibrated at 100 centimeter SSD and the physician wants to treat at a different SSD, whether that be 80 centimeter SSD or 130 centimeter SSD. Okay, more often than not, the physician will choose to treat at a larger SSD because it's usually on some sort of a spine field where they can't get the entire spine into the collimator size, so you have to treat it in an extended distance. Whatever the reason is, most likely that's going to be the case for your board exam question, is calculate the Mayneord F factor for these two different SSDs for this energy at D max and calculate it to this depth. Okay, this is the equation. 2, 1, 1, 2, D max before depth. If you want to see how it's derived, you're more than welcome to look in either Khan or at John Smith's nice little PDF that he has on the website. So, what is the Mayneord F factor? Real quick, the Mayneord F factor is a percent depth dose modifying factor. Okay, you will get a percentage when you're done with this Mayneord F factor. You'll get something to the effect of 1.03, 1.045, 0.98, 0.95. You'll get something right around 1.0, a little above or a little less. And what this does is it modifies the percent depth dose for your hand calculation to account for calculating a different SSD. Because, as you've learned in the class, percent depth dose is dependent on SSD. As you change the SSD, the percent depth dose changes. So how do we calculate this? Let's give an example. Let's say your machine is calibrated, let's say 6x, okay, so 6 MV. Machine's calibrated to deliver 1.5 centimeter depth for a 10 by 10 squared field size to deliver 1 MU equals 1 centigrade at 100 centimeter SSD. So those are your reference conditions. Okay. Now in your hand calc, you come in on the weekend, it's an emergency sim and treat patient, this guy's doctor wants to do a PA spine. Okay, so your machine is calibrated at 100 centimeter SSD. So he flips the patient on his stomach and he says to you, okay, well, let's set up a port film field. So he sets up the port film field. He says, no, I can't get the whole spine in. Okay, we need to treat at 120 centimeter SSD in order to get treated what I want to treat. Okay, so he looks at you and says, is that going to be a problem? Well, no, it's not going to be a problem because you've remembered 2112 Dmax before depth, and you're going to be able to do this hand calc without any problem. So you look up all your tables and whatnot, and then you come to modifying your percent depth dose factor before calculating the monitor units, and you realize you need to do the Mayneord F factor. So what do? Mayneord F factor is going to be SSD2. Oh, I should have wrote in here, he wants to change to 120 centimeter SSD. Okay, so SSD2 is going to be 120. Dmax for 6X is going to be 1.5 centimeters. SSD1 is 100 centimeters plus Dmax. This whole quantity is squared. Second quantity is going to be SSD1, 2112 Dmax before depth, is 100 centimeters plus depth. The depth that we want to treat to is 5 centimeters. And that's just what the prescription from the physician is, 5 centimeters. I'm kind of making that up on the fly. SSD2 is 120 centimeters plus 5 centimeters. And this whole quantity is squared. Okay, so what do we get? I got 121.5 divided by 101.5 squared. And I get 105 divided by 125 squared. Unfortunately, I didn't have my calculator in front of me. So give me 1 sec. So I get 121.5 and 1.5 divided by 1.5. 1.011. So what we do is to get our new percent depth dose, new is going to be your Mayneord F factor times your old percent depth dose. Okay? It's a percent depth dose modifying factor. Now you'll see another reason why a lot of people just ignore the Mayneord F factor is that at 20 centimeter change in SSD, I only got a little over 1% change in my percent depth dose. Not crucial. Okay? So I would encourage you as an exercise and practice in remembering the mnemonic device. What I would like you to do, and I will not hold you accountable to this, for these reference conditions that I set up here, I would like you to do 80, 90, 100, 110, 120, 130, and 150. And I would like each of you to calculate the Mayneord F factor for all of these. At 100, this had better be 100%, so just 1.000. Everything here had better be smaller. Everything here had better be greater. All right?